Today we're going to talk about sex-linked traits. Sex-linked traits are traits that are located on the sex chromosomes. If you remember back to when we were talking about mitosis and meiosis, we talked about the fact that there are sex chromosomes and autosomes. Autosomes are your chromosomes that carry all of your traits other than those related to your gender. Your sex chromosomes are either X or Y. If you have XX, you are a female, and if you have XY, you are a male. Okay, so this is just a review from some stuff that we've already talked about that you need to remember in order to understand what we're going to do today. Many sex-linked traits are carried on the X chromosome. That means that females can have three options. Males either have the trait or they don't, since they only have one X chromosome. So let's look at an example. Eye color in fruit flies is carried on the sex chromosome. For females, they have two X's. It can be carried on either or both chromosomes. For males, it's only going to be carried on their X. So for a male to be red eyes, it has to have at least one dominant trait. And for it to be wide-eyed, it would only have to have one recessive allele. But for females to be white-eyed, having the recessive condition, it would need to have two recessive alleles. So in this example, we're going to cross a red-eyed male. XY indicates that it's male, the capital R indicates that it's red, and a white-eyed female. The two X's indicate that it's female, and the two little r's, or lowercase r's, indicate that it's white-eyed and has the recessive trait. Remember, the Y chromosome in males does not carry very many traits. So these are our options. If it was a red-eyed female, it could be big R on the X's, or it could be big R little r on the X's. Notice that it's XX both times because we're talking about females. It can also be a white-eyed female, which is when it has two lowercase r's. These are all of our options for females. If it's a male, it's going to have XY, and to be red-eyed, it has to have one big R, and to be white-eyed, it has to have one little r. So here we go. We have XRY for the father, right here, and we have XR for the female, who's white-eyed. We fill it in just as we fill in any other Punnett square. However, when we do phenotypes for sex-linked traits, we need to specify if they're male or female. So in this case, we're going to have 50%, or half of our individuals, that are red-eyed and female, and half of our individuals are white-eyed and male. So question, in humans, color blindness, two little c's, which means it's recessive, is sex-linked. Remember that a female has two X chromosomes and that a male has an X and a Y. Two normal people have a colorblind son. What are the genotypes of the parents? Well, we know that if the father is normal, he has to have XY with a big C. If the mother is normal, she definitely has one big C, but she could have another big C or a little c. Since her son has color blindness, we know that he has to have the little c, and therefore she has a little c. So I test my crosses. I have my father on the top and my mother on the side. If we have mom having a little c as her second allele, then she can have a son, which is right here, who is colorblind. So 50% are going to be normal. One's going to be completely normal, the other is going to be a carrier. A carrier is a vocabulary word that you should know, meaning that it is heterozygous. It has the dominant allele and the recessive allele, meaning it can pass the recessive allele on to offspring. It also has 50% male, but one's normal and one is colorblind. Here's my normal, here's my colorblind. A couple has a colorblind daughter. What are the possible genotypes and phenotypes for the parents and the daughter? Well, if the daughter is colorblind, it means she had to get a recessive allele from mom and a recessive allele from dad. Therefore, we know that dad's genotype must be X little cy. Mom's genotype could be X big C, X little c, and therefore we have the option of having the parents be X little cy and X big C, X little c, or mom could also be colorblind and have two little c's. This is a pretty rare case that mom is colorblind. The father is definitely colorblind, but the mother would be a carrier, meaning she could give the little c even though she doesn't show colorblindness, or she could be colorblind herself. The daughter is definitely colorblind, meaning that the daughter's XX, showing that she's female. For sex-linked traits, which are carried on the X chromosome, males get the trait more often than females, and if a boy has the trait, he had to get it from his mother, since he only gets one X and the X is from mom.